Welcome, deer hunters, managers, and enthusiasts. This is Deer University, the podcast of the Mississippi State University Deer Lab. My name is Bronson Strickland.
And I'm Steve Damaris. Bronson and I are professors of wildlife management and co-directors of the MSU Deer Lab. Together, we've researched deer across the United States for more than 40 years. In our podcasts, we explain the why and how of deer management based on science. Whether it's research we've conducted or explaining research done elsewhere, we'll offer you a college course in the science of deer management.
But don't let Steve scare you. This isn't going to be a review of calculus or chemistry. Instead, we take results of research, reduce it to what's important, and explain how you can apply research to management. So join us for this episode of Deer University. Welcome back to the next episode of Deer University. Steve is back finally from his tour of the world. Marcus and I mentioned in the last episode how we had been traveling all summer long. Not all summer long, but lots of trips to go to conferences and so forth. And Steve, you've been gone a lot longer.
Yeah, I had a fantastic trip to that conference in southern France where we met with the International Union of Game Biologists and interacted with deer nuts like us from all around the world. Mm-hmm. We learned a lot. They learned something from us, and it was a great experience.
One thing that was interesting, Steve, that we noticed over there, they're dealing with a lot of the same issues in Europe that we're dealing with in North America. And I know the topic I spoke about was wild pigs or wild hogs, and they're dealing with wild boar, and hunter numbers are declining, just like they are in the U.S., but human population numbers are increasing, and so obviously are the animal populations in terms of wild boar, roe deer, red deer, and that's just a recipe for negative interaction, conflict, both with road collisions, crop damage, forest damage, etc. So a lot of the issues here are paralleled in Europe.
Oh yeah, and oftentimes we hunters kind of complain among ourselves that we don't have as much access as we would like, or if we lease it, it's an awful lot of money we have to pay. But it's really we have it much better here in the United States in terms of the amount of public land access and the general access for hunters. Even in Europe, they have very technical regulations determining who can actually be a hunter. So you can't just take a 3-night hunter safety course and go get a license. Yeah. It's much more complicated and expensive. So we're really blessed in the United States because of the system that we have.
And it's also that time of year. So here in Mississippi, we have what's today? About 10 days, maybe 9 days before archery season begins. And so we know our listeners are, in some places I know deer season's already opened up. It opened up in August in South Carolina. So it's been open a while in some places.
How's your practicing coming?
Not as much as I would like to, but I have been out shooting my bow quite a bit. I've had several sessions, and I'm pretty confident at 30 yards. I prefer a 20-yard shot. I'm confident at 30 yards, 40 yards.
Let me get clarification here. You're confident or competent? And is there a difference there?
I think I am. Yes, there is a difference. I am confident in my competence. How's that?
Okay.
At 30 yards.
Okay.
40 yards, I'm not as confident nor as competent at 40. Okay. The groups start getting wider and wider. Yeah. And I guess that's the combination. Can I blame it on just getting old?
Sure.
I guess I can. The bottom line is I don't practice enough.
Yeah, that's my problem.
I don't have the muscle memory, and I'm shaky at 40, and the one thing I have every year I say I'm going to try to improve upon is discipline. Rather than when that pin or crosshair, it's dancing around the target and you just kind of time it. when the pin on your bow, when it's kind of getting near the target, the bullseye, you kind of let it fly.
Mm-hmm.
I've always wanted to be a more disciplined archer, like professional archers, where you're supposed to shoot a bow like you shoot a gun when you have a rest. You hold it on the target and you squeeze, squeeze, squeeze while it's on the target, not while the crosshair is dancing, back and forth. But I have yet to achieve that level of archery zen yet.
Yeah, and you don't have that rest.
Nor do I have a rest.
It's your arm, and that's about it.
Probably even the coffee. Maybe the jitters.
Yeah.
From all the coffee I drink too.
Well, I have a confession. I'm a 20-yard man. Above 20 yards, I'm not confident.
Yeah. Well, that's my favorite shot. All my setups, if the deer do like they're supposed to do, I try to have my setups between 15 and 25, not only for my competence and confidence, but the further that deer is away from you, the more stuff can go wrong when the arrow leaves the rest.
Sure.
I mean, instantaneously a duck, a turn, a move, and you went from a miss to a hit, or you went from a good shot to a gut shot. So that's why I really like them in close.
Mm-hmm. Do you have your mineral stumps created near your stands to bring the deer in?
Confession I must make. I cannot tell a lie. I don't, but the good Dr. Marcus Lashley has created quite a few mineral stumps.
Okay, so we can hunt near his stands.
Yeah, we don't need to let him know about it, but yeah. No, he will know about it too because he has cameras on it.
Yeah.
So
yeah, and he listens to the podcast.
Yeah. So we'll have to depend on his generosity.
Yes.
Bottom line.
Thank you, Marcus. You're a wonderful man.
Well, what we want to talk about today, Steve, is the rut. That's the general topic, and you and I on our MSU Deer Lab website, we've kind of broken that topic into two different themes that we call the biology of the rut, which is kind of the physiology of the rut, meaning the hormone differences that are taking place, how that changes the animal, and hence how that changes their behavior. And then we also have what is called the ecology of the rut, and that's more of the big picture interactions. Why does it vary from place to place? How it changes over time? That type of interaction.
How adult sex ratio might alter the timing of the rut.
Yeah, absolutely. So that's kind of our theme for today. We've already gotten some feedback from people, that hunt in different parts of the country where the rut is a lot earlier than it is here. So I'm not really thinking about the rut at all. I'm thinking about early bow season patterned deer right now. But in about, a month from now, in a lot of places, they're going to be in the pre-rut phase in terms of that ecology of the rut.
Yeah, at least 2/3 of the range of whitetails in North America, the peak of the rut is early to mid-November.
Yeah.
And so, come bow season in October, you're getting ready. You're starting to worry about it.
Yeah. In Mississippi, by contrast, our probably on the average across Mississippi, we really don't start seeing activity until December, and in most places it's mid-December. And then you get to the southern part of our state, and heck, it's well into January and sometimes February.
Yes.
So why does it excite so many people? Why do hunters even care about the rut? Why is it a big deal in your estimation?
Because of the effect that the hormones on the male, in that he's driven to be more active because of his high testosterone levels. And I think we mentioned in the earlier podcast, but I'll remind us that between July and August, as the antlers are in final stage of development, the testosterone level of a buck goes up from 0.5 units up to over 20 units. Now and the units are nanograms per milliliter, but just think of it as a 0.5 to over 20. That's a 40-fold increase in testosterone.
The concentration in his bloodstream?
Yes.
Is that, forget about the units, but the concentration of that hormone pumping through his veins and flesh.
Absolutely. And if you think of the difference in behavior and attitude of a 10-year-old boy, totally pre-pubertal, no or limited testosterone level, versus the behavior and attitude of a 17-year-old boy that is ripening in his testosterone production. That's the kind of change in behavior that takes place within a month of a buck's life. And if there's a dad that's listening right now that's had a son go through that transition, or the equivalent transition for a female, impacted by their sex hormones, I mean, it's pretty dramatic.
Yeah, you joke and say it's a different animal, it's a different beast.
Yes.
The change and the effect that hormones have on us.
Yeah, and so that increased testosterone level increases the activity rates or the interest in breeding, which affects the movement patterns of bucks. And so hunters, I think, across the nation accept the fact that when breeding is peak of breeding, you're going to see more bucks because they're acting somewhat, well, I'll say, stupid. They're worrying more about breeding opportunities than about staying safe.
Yeah, and that's kind of something we've talked about, maybe not to a great extent, but when we talk about nutrition and feeding and all that sort of stuff, we kind of delved into what we call optimal foraging theory, which kind of means that the decisions that an animal makes of where it's going to forage is a combination of how many calories and nutrients can I get for the least amount of effort expended. Makes perfect sense. Why walk a mile for a meal when you can walk 100 yards for a meal? With the caveat that I'm not going to jeopardize my survival.
Yes.
So now I might walk a mile to get that same amount of food if it's less risky in terms of predators, hunters, stuff like that.
Yeah.
So, but now when the rut is involved, that whole risk of living and survival, he kind of throws that out the window to a great extent.
Yeah.
He is totally focused on mating and breeding.
Because one thing matters to a wild animal, and that's getting his genes into the next generation. If he doesn't, then he has not succeeded ecologically.
Right.
He's a dead end.
Yeah. So that's always the motivation, is passing on your genes, a term we call fitness. And you do that over the years through living a long life and producing a lot of offspring. You're a very fit individual.
Yeah.
And so that's the common goal of all animal life.
So that behavior that's driving them affects their visibility to hunters, and that's why this topic is of so much interest to hunters. I've had so many calls related to our breeding date map that's on our Deer Lab website, and then the State Wildlife Agency here in Mississippi has a breeding date map, shows the different timing. There's a lot of variation in Mississippi. We have pockets and such. I've had so many calls over the years of people saying, well, I'm hunting in such and such a location. Can you help me interpret the breeding date map and help me determine exactly when I should book my hunt? Say, like people that are calling in about booking a commercial hunt somewhere. They want to fine tune. Should I do it Monday through Wednesday or Thursday through Saturday? I mean, it really, I don't know if it's that important, but it certainly does matter to hunters. And you've probably had experiences in your own hunting life that exemplify.
Oh, yeah. Yeah. But both in research and hunting. I mean, we've all had those experiences research-wise where when I was in Texas and we had a field experiment where we put up temporary enclosures. They were about 1 acre in size. And so this particular trial, we were monitoring food intake. So we had these tame does, bottle raised, and they were more or less tame. And we put them in these enclosures and we monitored what they ate, how much they ate, how it contributed to their change in body weight over time. And when the rut came, though, in South Texas, I can still vividly in my head remember one instance where it was a yearling buck, But one of the does in my enclosure was in estrus, probably in standing heat, ready to be bred. You couldn't run the little guy off. So I think I maybe got within 20 yards of him or something like that, and he would bat an eye and look at me, but he really wasn't paying me any attention. And I would clap my hands and pick stuff up and throw it at him, and he would jump in the brush, but within 10 to 15 seconds he was right back. So that's the magnetic attraction that these bucks, they are no caution whatsoever. They are singularly focused on that breeding event. And then, of course, hunting scenarios over the years, we've all witnessed, if you've spent any time in the fall, the magic day or the magic occurrence where that one doe that is in standing heat or about to be comes trotting by, walking by, running by, and then all these bucks follow. And that is a really, really cool thing to see. Their nose down, trailing her, literally looking like a hound dog, trailing her and following her. And you had an instance in Texas too, where I think you had
I was sitting in a
five,
blind
six,
on a
seven.
food plot, and mid-afternoon, this doe just trots into the food plot, trots across the food plot, and goes into the brush on the other side. And then just literally a minute behind her comes an 8-point buck, and then 30 yards behind him comes another smaller 8-point buck, and there was a line of, I think, 7 bucks separated by about 30 yards following along behind each other. And it was kind of a comedy once they all went into the brush across the food plot. And so I'm watching it, and apparently the brush was so dense that she got kind of lost from the other bucks. And it was like every once in a while a buck would pop out into the food plot and kind of look around and then jump back in, trying to, where is she now?
Mm-hmm,
She's not out here. I'm going to go back in. And it was, over about an hour's time, this was happening. And then eventually she headed back out in another direction across the food plot, and they all followed along behind her.
So that's kind of a good lead into our biology of the rut. Why don't you explain a little bit physiologically what's going on there? So I would offer to you, she is shedding or exuding the scent or smell.
Mm-hmm.
Volatile organic compounds are going in the air. That is a cue to bucks that are in the area that smell her that she is nearing standing estrus. But evidently she was not quite ready yet.
She was close but not quite ready. And there's literally a 2-day window during which a doe will allow herself to be bred. And if she's successfully bred and the fetus implants, that's it for her for the year. And it's a process, a hormonal process of estrogen and progesterone building up, and time to the season of the year, and genetically controlled in part within her when her breeding date should be. And when it's all finely tuned and everything is lined up, the hormone concentrations are right, and she's in good enough condition, she's going to come into estrus. And it's literally flipping a switch. It's a gradual increase in the hormone levels over about a week's time, but at some point there's a non-standing estrus where she starts getting attractive in terms of her odors, but she's not quite there yet.
Mm-hmm.
She's not ready to be bred, and that's when you get a lot of this chasing behavior. And when she's ready to be bred, it's a different story. She will stand and allow herself to be bred, and in those situations she's not nearly as mobile. Many of us have seen cases where there's a doe and a buck just kind of walking through an area, and the doe will bed down and the buck will bed down next to her. This is during that day or so when she's actually in standing estrus. It's a different behavior. They have come to know each other well, and they're hanging together.
Mm-hmm.
Now, you can have other bucks coming in and challenging that buck for the position of being with her, and that often happens.
that speaks to the multiple paternity
Yes.
that we documented years ago, that Randy DeYoung documented, that 25% of the time twin litters are going to be sired by a different father.
That's right.
And so that's within, Steve, right, that 12 to 48 hour period where she is receptive that she's getting bred multiple times.
That's right. She actually ovulates towards the end of that period, which I find interesting, and that she finally allows herself to be bred, but she hasn't necessarily ovulated yet. And there's probably a lot of reproductive physiology and behavior that we could talk about there, but that's a little deep.
Yeah. So take home message, she's getting bred before she ovulates, but sperm is being stored in the fallopian.
Yeah.
And so eventually they're going to unite.
Yes.
So she can have a little lead time
Yeah.
because of that.
Yeah, she doesn't want to ovulate an egg into an area where there is no sperm.
Yeah. Yeah. Okay. I noticed when you talked about hormone levels and her getting to that threshold of hormone levels where she's coming into standing heat, you never mentioned the four-letter word. It starts with an M, it ends with an N, and there's two O's in the middle.
Moon phase, yeah.
The moon, yeah.
Yeah.
I thought that's what controlled the rut, was the moon.
Yeah, short answer, no. The timing of breeding has nothing to do with the moon phase per se. The general pattern of the amount of daylight and the amount of dark determines whether or not breeding season is in or out. And there are short day breeders and there are long day breeders. Long day breeders breed in the spring when days are becoming longer. Most birds are like that. Robins build their nests in the springtime. Rabbits start breeding. Lots of animals breed in the springtime. Deer are short day breeders, meaning they breed when there's less light relative to the dark. And so there's a general pattern. Now, that pattern is regulated by the relative amount of light and dark in the season. And within that general pattern, the individual's genetic propensity for when she's supposed to breed generally sets the pattern, and then that pattern is driven by when her hormones get turned on for that year, and that's going to tie back to the amount of light and dark, and then sometimes her condition, her nutritional condition, her physiological state can affect the exact timing of that. Some of our work in our deer research pens showed that if a doe successfully brought two fawns to full recruitment, lactated, the demands of lactation, she produced two fawns and brought them through weaning. She would tend to breed about 5 days later that year than she would another year where she didn't have that nutritional and physiological demand. So there's some variation within a week or so based on the nutritional and physiological stress of a female. But then generally, an individual is going to breed pretty consistently from year to year, and that sets the population breeding pretty consistently from year to year.
I think it's important to, because I'm a nerd and I always want to know why. This and that is what happens. We always want to know why. Now, why is that? And so a lot of people think, and I can't criticize them for it, because probably before I became a biologist I would have thought it too, that it would be weather. The season in terms of temperature, it's getting cold. That's going to be the trigger of when she would come into heat and breed. But instead, it's this ratio of daylight hours to darkness hours, which we technically call photoperiod.
Mm-hmm.
Photoperiod is the trigger.
Yeah.
Now, let me ask you, wildlife biologists, why use photoperiod and not weather?
Weather is too variable. What we're talking about here is a deep time adaptation to patterns of weather, which is what we call climate. And so a deer population shouldn't be responding to an individual weather event. They need to generally respond to the pattern, and because that's what you bet on. As a deer, you're betting on your fawns surviving and being produced at an optimum time of the year. And so it's really the survival of the fawn that drives when a population of deer is going to be breeding. That's why in the northern United States, which have very extreme winters, long winters, the timing of the fawn's birth drives when the females will breed. Because if a female produces a fawn too early, when it's still too cold, it's going to die. If it produces it too late in the spring, when it's already nice and warm, that fawn won't have the time to grow as large as it needs to before the next winter clicks in again. And so it's going to die of exposure because it's too small and
hadn't
undeveloped.
reached that critical body mass size to thermoregulate during those harsh winters.
Absolutely. And so it's that cold winter that drives the timing of breeding ultimately. And that's why 2/3 of the range of whitetails, the populations breed early to mid-November, because that's when their fawns can be produced 200 days later and survive. Some years it might be a little too early, having a late winter, they might not do as well. But on average, they're going to do better being out earlier than they would if they came out in July and didn't have time to get big enough to survive the next winter.
And what's really to me interesting that proves that point is when you look at just the opposite. So what we say up north, that's relative term, right? So let's say Ohio, Iowa, and north of that. But now when you go to the extreme south of us, so we're looking at the southern, central Florida and south, and then when we get into essentially central Mexico and southern Mexico, when we get into those tropical regions, just the opposite happens. You have that strong selective force of winter. Winter is governing the optimal time for a fawn to be born, so it'll survive. But when you get in those tropical zones where it's essentially the same climate or weather year-round,
that's right,
you have animals in rut year-round, because there's no best time to have a fawn, because the vegetation, the temperature, everything's uniform year-round. And so those few projects we've been, and there was one I remember in Panama. I was looking at some camera data from that a couple years ago, and you would see that. You would see some bucks in velvet, some in hard antler. You would see, in talking with the contacts there, but breeding is occurring year-round down there, so just the opposite.
Yeah, and that doesn't mean that individuals are breeding year-round. An individual is still going to have her date of breeding, and a buck is going to shed his velvet, be in hardened antlers, and be capable of breeding during a certain time of the year, and then drop his antlers. But so individuals still have that same pattern of a time of breeding, but then across the population, because there's no pressure to kill off some proportion of animals that are born during a certain time of the year, there's just a hodgepodge of breeding dates.
So an individual has their, and I'm talking about females nowadays, their ideal time, that window is more or less fixed, genetically determined and fixed. So they have a window at which they are going to ovulate, go into heat, and from year to year to year until she dies, it's going to be pretty much within that window. But at the population scale, in an area is made up of individuals, a lot of them have a very similar window, but there's going to be differences. Some are going to be relatively early, some are going to be relatively later. And depending on that wintertime selective force governs how tight that population, the bell curve of breeding dates for that population will be.
Yes.
Because, Steve, we see, in the South, and especially south of where we're at in Mississippi, heck, you can have breeding can go on for 6 weeks, 2 months. You can see fawns being dropped then accordingly, during the summer for 2 months. But in other places, it's not that case, and that's because where we're at, we don't have a strong selective force for that fawn is going to live or die because it was not born at the optimal time.
That's right. There's no limit, much less pressure.
Yeah.
Now, within, so across the state of Mississippi, we have about a 4-month swing in birth dates of fawns, because we have in the northwest part of the state, we have breeding in November, and then in the far southeast part of the state, we have breeding well into February. And so birth dates, you could have a 4-month variation in when a fawn is born. Now, interestingly though, at the local level within a population, we still tend to see that roughly 5-week, 45-day period where there's a pattern of breeding. But across the state, there's much more variation.
Well, Steve, why don't we cover something that is really interesting, and that is that there's so much variation in when the rut occurs, of course, across the range of the whitetail in North America. But even, let's say, within the southeast, there's a lot of variation. And then when you get into a particular state in the southeast, there's a lot of variation. And when you get into half of a state, there's a lot of variation. That was a topic that you and a student named Jason Sumners tackled years ago. And if I remember correctly, the question kind of began with, I think this was in southwest Mississippi and literally in adjacent counties. I mean, was that right?
Yeah,
adjacent
nearby,
counties?
yeah.
There was about a month difference? Am I recollecting correctly?
In some breeding patterns. And this was actually a multi-state project. It involved Mississippi, Louisiana, and Texas. And we knew about places in Florida also that had a lot of variation in breeding dates in close proximity. And so biologists had been kind of making these observations for a number of years, and ours was an organized attempt to actually look at the genetics associated with those variations. And so what we did was set up a study. It was a paired study where we had these localized variations. A population, on average, they averaged 25 miles apart from each other, and if they either differed in breeding dates, and those that differed averaged about 30 days difference in breeding dates. So a big difference in breeding dates, close proximity, on average 25 miles. Okay, so that's a big difference.
Very big.
Close proximity. And we had, I think, 8 or 9 pairs of populations like that across Texas, Louisiana, and Mississippi. And then we had other pairs of populations that were in close proximity, 25 miles on average, that had the same breeding dates. And so that was kind of like our control. Mm-hmm. We wanted to know, is there a genetic difference between the populations in close proximity that differed in breeding dates? And the way we did that is by comparing their relative differences with the relative differences between close populations that didn't differ in breeding dates. Mm-hmm. Now, there's 2 different types of genetic material we can study. One is called nuclear DNA, and that's the kind of that's passed equally by the male, the father, and the mother. It's in all offspring, they have half of their nuclear DNA from the father, half from the mother. And then there's mitochondrial DNA, and that's the sneaky DNA, I like to think of it as. The male and female both have mitochondrial DNA in them, But once the sperm fertilizes the egg, the egg part of that, now the, help me with the term, zygote, I believe is, or gamete,
Yeah.
the fertilized egg. It is now a complete genetic set of material. Somehow in that egg, the fertilized egg, the female mitochondrial DNA is left intact, and the male's mitochondrial contribution to that egg is destroyed. Sneaky.
Yeah, very
So it's
sneaky.
that sneaky mitochondrial DNA. The female is the only one whose mitochondrial DNA is contained within the offspring. The male's mitochondrial DNA eliminated.
The nuclear DNA is still there, but the mitochondrial DNA is only from the mother.
That's right.
Yeah.
And that those differences actually allow us to make some interesting observations, and we use that difference in this study. We compared
That was the university part of Deer University.
yeah,
Getting in the weeds on the genetics part.
Yeah, sorry.
That was your college course university part
yeah,
right there.
yeah. Sorry.
Let's get away from that and talk more practical now.
Okay, so we looked at the relative differences in nuclear DNA, the part that is contained by the male and female and shared equally by the offspring, and the nuclear DNA essentially differed in the same relative amounts between pairs of populations with the same breeding dates and those with different breeding dates. And this is explained because the males contribute equally to the nuclear DNA. 25 miles to a male is not a big deal. We have males dispersing 10 to 12 miles. So within 2 generations, you could have males blending between 2 populations.
Mm-hmm.
Now we know that females don't disperse nearly as far from their birth region, birth area, their mother's home range. And so what we found was the mitochondrial differences were very limited in the pairs of populations with the same breeding dates, meaning the mitochondrial, the female DNA was relatively similar where breeding dates were similar. Now, in those 8 or 9 populations where we had different breeding dates, we found significantly more difference in the mitochondrial DNA of the populations that had different breeding dates. And so what that allowed us to conclude was there are genetic differences that relate to the different breeding dates in these populations, and probably they're maintained in close proximity because the females don't disperse as far as the males. And so again, that nuclear DNA that distributed by the males, that's all a wash and even. And then where there wasn't a difference in breeding dates, the mitochondrial DNA was evenly dispersed between the populations and didn't differ. The mitochondrial DNA, that female DNA, only differed where there was a difference in the breeding dates. So we think there's some genetic differences in the females that are regulating the breeding dates in those locally different populations.
So two things are going on there for that to happen. Just condensing it down a little bit, you've got the genetic marker. So this genetic tag or window is inherited by a doe fawn, and so she's going to have a very similar breeding date as her mother did.
Yes.
And then behaviorally, the much decreased dispersal demonstrated by females versus bucks. And so within that one area, that population or area, that is where you see that timing of the rut or breeding season maintained.
Yes.
And so that's how 30 miles apart you could have a population breeding December 1st and a population breeding January 1st and maintained over time.
Yes.
Inherit it from your mother, and then does don't disperse as often.
That's right.
Or as far, excuse me.
And the males, they're physiologically ready to breed once they shed their velvet and until they drop their antlers. So there's about a 4-month window there when he'll breed any standing doe that's in standing estrus during that 4 months. So it doesn't matter to him. The timing of the breeding in deer is controlled by the individual female and when her physiological machinery is ready to roll. That 2 days when she's ovulating and in standing estrus.
So like we've talked about before, but the other mechanism with this, well, you started with testosterone and the concentration increasing so much, which triggered velvet shedding.
Yes.
So we've always say when a buck is in hard antler, and until those antlers drop, he is capable of breeding.
Yes, and the reason they drop is because the testosterone levels drop.
Mm-hmm.
The reason the testosterone levels are dropping is because his testicles are shutting off testosterone production, and associated with that is the ending of production of sperm.
Again, even for bucks, governed by photoperiod.
Yes.
Yep. So that's telling him this time of the annual cycle is over. Now it's time to get rid of the antlers. Let's stop focusing on breeding 24/7, and let's start focusing on food and getting your body back in shape.
That's right.
Drop the antlers and start eating.
That's right.
So, Steve, in the South, well, we talked a moment ago about Mother Nature or the environment, being a selective force for when the breeding season occurs, which is it's directly affected by when's the best time for a fawn to be born. Okay, and we were contrasting up north versus south, and that selective pressure being the environment, temperature mainly. Why do we see so much variation in the southeast? Is any of that because of restocking back in the day?
It's likely that some of that is caused by the source populations that our state agencies back in the 1930s and 40s, they needed deer. Who has deer? Oh, Wisconsin has some deer. Let's bring some deer in from Wisconsin. Mexico has some deer. Let's bring in some deer from Mexico. They got deer from wherever they could. They were doing the best job they could. Those deer weren't necessarily adapted to where they were brought. And we've shown through some other genetics work that they generally weren't successful. But there may be enough success in some areas to maintain some breeding dates.
Mm-hmm.
So there's that potential restocking from odd places to a local area that may have caused a locally different breeding date.
Potentially an explanation for what you're describing with 30 miles apart or 25 miles apart, a 30-day difference.
Yes.
Could be due to the source population of where those does came from.
Yes.
Okay. And then so in that case, the environment was not strong enough to shift it.
That's right.
Yeah. There was no big selective pressure for natural selection to occur, that the ones that were born really early or the ones that were born really late really had a advantage in reproduction and survival. So it was just kind of maintained.
Yeah. Because they could.
Because they could. Okay.
And Bronson, there's a second possible cause of this localized breeding variation. We don't fully understand all of the adaptations that deer have within our southern populations. Like along the Mississippi River, and there's flooding patterns that might affect when localized populations are best adapted or best survival mechanisms or mechanisms for survival are best for their fawns. Maybe there's some parasite issues. Maybe it's a pattern of hurricanes hitting. Some of our populations that we studied in Jason's study were not restocked populations. They just differed naturally in their existing deer populations. So it's not all restocking.
Yeah. Environmental pressures.
Yeah.
Yeah.
So environment can drive breeding dates if they affect the survival of the fawns. Wintertime is a major driver. northern populations. In the south, it's not, but there might be other. If you've ever spent a couple of weeks out in the wet bottomland hardwoods and being carried away by huge mosquitoes, that just patterns of parasites and blood sucking mosquitoes and ticks. I mean, there could be some factors affecting breeding dates there locally that are related to some of these patterns. And I want to put in a plug for our former student and friend Jason Sumners. Do you know he's now the director of the Wildlife Division of the Missouri Department of Wildlife Conservation?
Indeed, I did know that. So kudos to him.
So proud of Jason, and just another example of a graduate student that got their training here at the MSU Deer Lab, and then because he's a really intelligent, hardworking individual.
We'll give him most of the credit.
Yeah, and partly because he was here at Mississippi State and worked, with us in the Deer Lab, he went on to have a really successful career.
Mm-hmm.
So, thanks, Jason, for all your hard work, and
sky's the limit.
Sky's the limit.
Sky's the limit. So let's wrap that little part up, Steve. Let's real simply, we talked about potential does inherit, their female offspring inherit a breeding date, a general window when they do. So restocking at some points could be responsible for some of the variation, but still the bottom line, the big picture, is the environment is always going to dictate when the rut is. Because when you think about natural selection and over time, there's going to be a diversity on the landscape of when those fawns are born. Mm-hmm. Might be a 30-day window, might be a 60-day window, whatever. But year after year after year after year, the ones that survive, guess what? They live, obviously, but they breed.
Mm-hmm.
And then that is genetically linked through the mitochondrial DNA.
Yeah.
So that's how that mechanism occurs. And so regardless of the restocking, if you were to have an environmental event, flooding, winter, viruses, parasites, etc., but over time the environment is going to sculpt the breeding date to be most advantageous for that population.
And before we leave this topic, I want to throw in one really cool fact about, we talked about photoperiod and the relative amounts of daylight and dark being the ultimate controlling factor that tells that female that she's coming into the breeding season and she needs to start getting her hormones in gear to breed at the right time that she's programmed for. If you took 10 does that here in Mississippi, and on average they bred the first 2 weeks in December, and you move them to the southern hemisphere where there's a 6-month flip in when winter is and when summer is, those does, after about a year of being confused, they will actually start breeding in the first 2 weeks of June in the southern hemisphere, because that's the right. In the southern hemisphere, June is the short day period,
right.
Not December. So they stay true to their genetic program date that is ultimately regulated by the light and dark cycle.
By the photoperiod cycle. I have known that for about 20 plus years now, and I'm still amazed when I think about it. Yeah, everybody would assume that you move her to South America somewhere, and she's going to keep breeding at the same time. But that is the strength of the photoperiod clock, is after that year or so of her to get recalibrated, so to speak, with the clock, and then she'll start breeding 6 months difference.
Yeah.
Yeah.
And even more, another example, extreme example of this, some researchers, and I can't remember their names or where they did this, but they actually condensed the 12-month cycle of photoperiod into 6 months and caused bucks to grow and shed their antlers within a 6-month period and then grow and shed a second set of antlers within a 6-month period. It's not how long they have them on that's regulated. It's the relative daylight and dark telling the animal, okay, now it's time to harden, and until the photoperiod changes, they're going to keep them on. But if that photoperiod change happens in half the amount of time, they're going to drop them and then start growing a new set.
I remember that study very well. And I thought they even manipulated it more than that, Steve. Again, this was 20 years ago. I thought they got it down to like 4 annual cycles were compressed in one. That they accelerated the photoperiod clock, they manipulated it really fast. But I would have to dig up that paper.
It's taxing my memory, but
Yeah.
photoperiod entrains the cycle that is genetically controlled within the individual. And that's the take-home message. And then that, whether or not, how that population responds is going to be driven by environmental conditions, whether it's cold winter, flooding, whatever. Survival of the offspring will change over time the breeding pattern of a population.
You know, I've never seen a study, Steve, I'm being quite facetious here, but just to make a point, I've never seen a study showing how manipulating the moon phase has that big of a impact on a deer population.
Yeah, you know, Mike Dye, another one of our former Deer Lab students who's now a biologist in Virginia. He looked at moon phase, and it looked at a huge database of known breeding dates of does and their fawning dates from research pens in Georgia, Mississippi, and in Texas, in a huge sample size, and looked at the pattern of the harvest moon and how it's supposedly regulating breeding dates at the population level from year to year, and it had absolutely no impact on when does were breeding.
There was a field component to that as well, because I
Yes.
helped him analyze the data, if you remember.
Yes.
But he looked at the research deer within pens, as you just discussed, and then we looked historically at data
Yes.
from the field, looking at not the individuals in that case, but the peak breeding. So we had all these successive years of when peak breeding from the Mississippi Department of Wildlife, Fisheries, and Parks from their collections.
Yes. The
Look
health
at
checks.
Yeah, the health checks. And so from year to year, the moon phase was varying, bouncing around a week or 6 days, a week, 15 days, whatever it is. But the peak of breeding was not changing.
That's right.
So the strength of that argument, I remember, was we did it both ways.
Yes.
We looked at individuals in confinement, and then we looked at it in the field, and in neither one of those cases was there any relationship of when the rut is or peak breeding relative to the moon.
Yeah. However, there are population characteristics that can affect breeding dates.
Do they affect breeding dates or the distribution at the population level?
Well, good point. It affects the average breeding date in a population. If you have major changes in sex ratio, adult sex ratio, you can have a lack of successful breeding because you don't have enough males in a population. And this was the case across Mississippi back in the day when it was only buck hunting allowed prior to doe harvest, and it was just to focus on removal of as many bucks as hunters could shoot. And normally that harvest took place before the breeding, and so come breeding season you might have properties with one buck per 10 or 15 does alive at the time of breeding. That buck cannot cover all the does that are when they're in standing estrus. And so what that happens is he'll cover one or two, and then the others have to miss an estrus and then they recycle. Because if they don't become pregnant, they recycle within this period of breeding, which is anywhere from 5 to 6 cycles if they're not successfully bred.
So, Steve, let's try to paint a picture here. If we have, let's say the ideal time would be December 1st. And normally, if the sex ratio was even, or even let's just say 2 does for every buck, then I'm sure there's an exception, but 99% of the time, when in that scenario with that sex ratio, when the does come into heat, there are enough bucks that are available to breed them on their very first estrus cycle.
Yes.
And in that case is where we would have a classic, total breeding may take 3 to 4 weeks, but most of it, let's say 60 to 70% of it, may be just in a week or two. That's where we would see that really defined,
Yes.
the peak of the rut, a week long, 10 days long. But the scenario you started with, now it's numerical. Numerically, there aren't enough bucks capable to do the breeding. So those does, for all the reasons you discussed earlier, all those does were synchronized to come into estrus around December 1st.
And they do.
And they are. And the bucks that are available, they're breeding all they can physiologically do. But there just isn't enough time because of their tending bond behavior as well. They're
Yes.
sticking with that doe that's in estrus. They're going to stay with her a day or so, depending. And then meanwhile, you have these other does that are in standing heat and ready to be bred, but there aren't enough bucks to breed her.
That's right.
So therefore, she will go out of estrus, and around a month later, 28 days later, she will cycle again.
Yes.
And so you would see this additional peak. And that's how in the old days, when we started looking at deer data from the 70s and all that time, heck, the rut would be spread out over months.
Yes.
Sometimes, because it was all these does having to recycle and recycle. But in most places that's not happening now.
That's right.
Certainly places that are managed, we're not seeing that at all. Numerically, there are enough bucks to cover all the does when they come into heat.
Yes. Now, that makes me think of another factor to throw in here. There is, a bit of a second rut peak. It's a much smaller peak, but about 10 to 15% of bred does don't successfully implant a fetus, even if they are bred and there's a fertile egg produced. It might not implant, or if it implants, it might, she may not have high enough progesterone levels to maintain pregnancy. So she's going to lose it, and she's going to cycle again about 38 days later. And then, so even where there's an even sex ratio, there's going to be a secondary hump 30 to 40 days later, when those 10 to 15% of the does that that didn't implant successfully, they're going to come back in. And then also doe fawns that are in good enough condition, that are large enough to reach sexual maturity their first winter, they tend to come in also, a percentage of them, anywhere from 30 to 50%. And so they're going to be much later than the usual peak of the population. So there is in existence a second breeding peak.
So in the old days, that could have come from three different reasons. It could be, like we spoke, numerically there weren't enough bucks to cover them, so they come into heat again. It could also be coming in from lack of implantation, physiological issue, problem. She didn't implant, she comes in later. And then fawns breeding. But so mostly what we see now is the last two. Implantation issues and fawns breeding. In Mississippi, I'm familiar with that because I've crunched the numbers so many times. So in a good area on a good year, based on our conditions, you might get 15% only about 15% of the fawns are going to breed, because we have a combination of two things going on there. A fawn's got to have enough time to grow up. So it's based on when the fawn was born and the amount of elapsed time that took place, because her coming into heat is based on her body mass and her fat, her condition. Contrast that with our buddy Mick Hellickson, who did the antler rattling podcast with me a few episodes ago, where he was from in Iowa. What he always told me was that up to and sometimes over 70% of the fawns would breed.
Mm-hmm.
So a combination, they have an early breeding season, and they have very good resources to eat on during the summer.
Yes.
He's in corn and soybean country, so those fawns can get larger and then be in great condition. So you would see a higher prevalence of fawn breeding in his neck of the woods.
That's right.
Versus here. I want to wrap up, Steve, with one thing, getting to the hunting aspect of the rut, and a term that hunters use a lot. I've heard hunters use it. I've seen on television hunting shows people use it. And the term is called the October lull. And my perception, I probably should have gone online and tried to read more about what it is, but to be honest with you, when I first started hearing this, my answer was always, the October lull is just simply the pre-rut. But as I understand what hunters are saying with the October lull is that when deer season began, looking at camera data, maybe during bow season, stuff like that, they're seeing a lot of bucks, a lot of buck movements, and then they reach a point, and wherever this theory or situation was developed, evidently that was in October. The October lull hits, which basically is these hunters aren't seeing a bunch of bucks until the rut hits. And then when the rut hits, bam, now it's getting back to when they're seeing bucks every time they hunt, etc., etc. So I have always thought that the October lull simply means that it's the pre-rut. And what's going on there is two things. Bucks may be minimizing their activity because hunters are now in the woods. As the podcasts are running together now, Steve, and I don't know if we've covered this in any great detail, but hunter activity does have a big impact on deer activity.
Absolutely, and we're going to have a future podcast on our research on that topic in particular.
That is currently going on.
And some of our previous work.
And some of our previous stuff, yeah. So the way I look at it is, in this particular area, I'm going to assume the rut is in November, like it is, like you mentioned earlier, in a lot of America. The rut is in November. So during October, you've got deer that are minimizing their daytime activity, probably because of hunter activity. But then what stimulates, as we've spoken about many times in this episode, what stimulates them to throw caution to the wind and start exposing themselves during the day is the rut. So I don't think of and also that term, the October lull, I don't think there's an October lull in Florida versus South Carolina versus Mississippi. Now there may be an October lull in Indiana or Ohio or Iowa, because October is the month prior to the rut month, which is November.
Yeah.
So if we wanted to say a lull a month in Mississippi, where we're at, we'd have to say the mid-November lull to the mid-December lull, because that's going to be our pre-rut time of the year before the rut gets going.
Yeah.
And you know what too, Steve? Lull may be normal. Maybe it's not so much that it's a lull, it's just that that's normal buck behavior. It's that during the rut you see abnormally elevated behavior during the rut.
Yes.
Yeah.
And that's in comparison to, your scouting pre-fall, late summer scouting when, bucks are in their buck groups, and you get photos of 4 or 5 bucks coming up to a camera maybe on a mineral lick or something. And you think
mineral stump, Steve.
Mineral stump, yes. Yeah, you don't need the mineral licks anymore. You have all these bucks that you're seeing, and then you stop seeing them as much. And so it's not that there's a lull in their behavior. It's just a change in their behavior. And you've gone from no testosterone to fresh testosterone, and then testosterone being impacted by the estrogen and progesterone in the does and their expressed behavior. So yeah, I don't know if I would call it a lull either.
Yeah. Normal. Just a normal part of the annual cycle of bucks, yeah. Well, Steve, we have covered a bunch, and you know what I bet? You know what I'm willing to bet?
What's that?
I'm willing to bet that we still did not answer everyone's questions about the rut.
Yes.
So these are things that we think are important from our deer biologist perspective, but I bet we did not address every question a listener may have. So as always, we invite anybody to contact us, on our webpage there. Send us an email and let us know, and we will do our best. We'll probably do a Q&A episode here pretty soon as well.
Yeah.
And so if it's questions about the rut, or I may have completely botched the October lull too. I may have completely missed the mark, and someone may say, no, you dummy, the October lull means this.
Yeah.
And so I will admit I'm wrong and I missed the mark.
And maybe I could show some of my pictures from my trip to France in the next episode.
Remember, this is audio.
Oh.
Audio.
Okay.
So you can talk about those pictures. Well, Steve, we will wrap it up there, and you need to go shoot your bow.
Yes.
You need to practice.
Yes, and I have to make it to Jackson for an important landowner cooperator meeting tonight. We're meeting with about 70 landowners occupying about 50,000 acres on a current project that we're working on, looking at how buck movements are affected by hunting activity.
I cannot wait for the data to start rolling in on that. We are going to have a feast looking at those data.
Absolutely.
I'm looking forward to it. Okay, well, thank you, Steve. Thanks for your time, and thanks everyone for listening. We'll catch you next time on Deer University. We're glad you joined us today and hope you learned something valuable about deer management. If you have questions about this podcast or a question about a topic we haven't discussed, please log on to msudeerlab.com, click on the Deer University tab, and send us your questions. We'll get to them as soon as possible. In closing, we want to thank our employers, the Mississippi State University Extension Service and the Forest and Wildlife Research Center. We also want to thank the St. John and Dudley Hutchinson families for their endowments that support deer research and education.